Hi, I'm Luke. I'm here to deliver some introductory material for CTFs. I'm with Pico CTF, and we've recently started a collaboration with NSA's Gen Cyber program. So we're going to start with general skills in CTFs. General skills isn't a category that's present in every CTF, but it's present in Pico CTF. It's kind of a grab bag of different challenges, and in Pico CTF, it's especially more introductory challenges. So first, we're going to start real simple. We're going to look at numbers. Then we're going to look at encodings and how numbers play into encodings. Then we're going to get our first problem set from the Pico gym. In the second half of this lecture, we'll talk about the shell. And then we'll finish with our last problem set. One of my favorite movies is The Matrix. And in it, there's a scene where the protagonist, Neo, goes to the Oracle's apartment to find out his destiny. And there he finds a boy bending spoons, apparently with his mind. And Neo, curious, goes up to the boy and asks what he's doing. And the boy says that he's not really bending the spoon, he's just realizing the truth that there is no spoon. And that kind of mind-bending abstraction is what we're going for with numbers in this lecture. But first, a picture of a spoon from crayon.com. Crayon.com is an artificial intelligence art generator. So all I did to create this image was I typed in the words bent spoon, photorealism, 4K, hyperrealism, and there really is no spoon because this is a completely artificially generated image. And actually, I use a lot of these images through my presentations because they're really easy to credit and avoid any copyright issues. So you'll see some more going forward. So binary numbers. Most people will have heard of the word binary and even know that it relates greatly to computers. But in this lecture, we're going to look into what binary really means when it comes to numbers. You may have heard of this joke before. There are 10 kinds of people in the world, those who understand binary and those who don't. And it's okay if that joke isn't funny right now or later, but you'll at least understand it by the end of this lecture. Numbers represent quantities. That's the raw part of numbers, is just quantity. We write numbers using digits, like 1, 0, 2, 3, 4, 5, so on. And a concept that might be new to you, probably is new to you, is base, numbers base. So the digits of a number can mean something different depending on what base they're written in. So quantities. So this picture of colored pencils. There's about 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of them aren't completely crystal clear as to what's happening. AI art generators are really cool, but there's always some kind of artifact that they leave that kind of gives you a clue that it's generated by a program instead of a person. But they're great for stock pictures. So there's 10 colored pencils. One way to write that is X, which is a Roman numeral for 10. Another really simple way to write that is in tally marks, in 10 tally marks. Tally marks are interesting because they're hardly an abstraction at all. There's as many lines as there is objects that you're counting. So it's almost like a one-to-one relationship. And then, of course, 10, as we're used to seeing. just very expected. What about 1 million colored pencils? What does that look like in these different numbering systems that we've just introduced? So in Roman numerals, it actually looks like capital M with the bar over the top. In tally marks, it's hard to actually write that because it's, well, a million tally marks. And in normal numbers, we see a million is just 1 followed by 6 zeros. Well, that's nice. That's a really even number. But what about 999 color pencils? You can see the Roman numeral kind of gets a little wacky at this point. Tally marks, same problem. You just have one less tally mark, but you still have almost a million. And with normal numbers, of course, it's pretty expected. In fact, I didn't even try to express 999,999 without using normal numbers because it's just a bit awkward. So one thing that's been in common with the normal numbers that we've been looking at is that they've all been in base 10. People like to say that base 10 is our normal base for numbers because we have 10 fingers. So I don't know if that's true or not, but it seems plausible. But there are actually many more bases than just base 10. It's actually kind of infinite bases because you can base it on any number. But we're going to look at the more common ones. And binary being the most common, it's base 2. So that means that there's 2 digits used to represent numbers. With base 10, there's 10 digits used to represent numbers, 0 through 9. With base 2, it's 0 through 1. So here's our normal numbers on the left side and their corresponding binary representation on the right side. So these numbers on each line are equal quantities. They're just represented in different bases. And base 2, being binary, is all ones and zeros. And so that's a very helpful way to represent numbers for computers because they have bits, which are just 1 or 0, on or off. You could write 10 in base 2 with all these leading zeros to make it line up with the rest of your base 2 numbers. And that's the same number. And technically you could do that with the base 10 numbers as well. It's just not as normal to see that with base 10. So here's binary counting from 0 to 17. So 0 and 1 are actually the same in base 10 and base 2. But when you get to 2, base 2 is run out of digits to represent numbers, so it has to start over. And so that becomes 10. And to get to 3, you're basically just adding 1, so that's why it's 11. And when you add 1 more, it overflows, and the 1 comes down, and it goes to all zeros on the right side. And then you add 1, and the 1 goes in the ones place. And then you add another 1, and that 1 overflows and goes to 1 in the space left of it, and then it's 0 on the right again. And that pattern kind of repeats going forward. It's good to just look at this chart and kind of try and pick up on the pattern of binary numbers. So hopefully you should understand this joke now. Maybe it's not any more funny than it was before, but 10 in base 2 is just 2. So that's why there's only 2 kinds of people mentioned. Yeah, with this picture, I input fist pumping robot next to an exclamation mark. But I got this thumbs up robot, which was pretty cool too. So I decided to include that. So what if you get a really big binary number and you want to know what it is in base 10? So to calculate that by hand, first you would copy down the number, and then you would start over here and you'd go 2 to the 0th power, then 2 to the 1, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, and 2 to the 5th. And if there's a 1 above the 2, then you add this value to your summation as you're calculating the decimal number. If there's a 0, then you leave it out. So most operating systems have a calculator that has kind of handy decimal, binary, hexadecimal converters. So I'll try and do that summation right now. So there's a 1 over 2 to the 0. So I add in 2 to the 0. That's 1. Then there's a 1 over 2 to the 1. So I add that in. Then there's a 1 over 2 to the 2nd. So I add that in. There's a 0 over 2 to the 3rd, so I skip that. And add 2 to the 4th, and add 2 to the 5th. Let's get 55. And with this calculator in Ubuntu, it shows you the binary representation also. And I can see that it's right because it's 110111. 110111. So I did that right. However, that can get a little tedious and cumbersome, so there's actually a better way to calculate binary quantities, and that's using a tool called CyberChef. CyberChef is available online. Takes a little bit to load. So if you want to convert that binary number to decimal, you would do from base. Drag this to your recipe, and then you'd say radix is synonymous with base, so you put 2 in there, then you type out your number. See, that gives the same output of 55. Other common bases, most common in computers is hexadecimal. You see that all the time. If you get into the weeds at all with any binary exploitation or reverse engineering, you're going to run into hexadecimal all the time. Octal, it's common, but you don't run into it nearly as often as hexadecimal. So here's a counting chart for hexadecimal. And as you can see, it's base 16, so it actually has more digits to use than our normal base 10. Whereas base 2 or binary had less digits to use, base 16 has more. And you can see that when you get to 10, it's still single digits. It's A and B, C, D, E, F, and it doesn't wrap around until 16. And CyberChef can calculate this as well for you. You just have to put 16 as the radix. You could put like 1A is a very hexadecimal number. 1A. See, it's 26, which is what the chart says, so that's good. There's a partner function in CyberChef. It's 2 base. So this takes a decimal number and converts it to a different base. Do 26, put that in base 16, 1A. We could try decimal number. $55. So he converts it to binary down here. There's a lot of cool things in CyberChef. Can actually be a little bit daunting. That's why they have this search bar here, so you can search for things that you want to do with input. We'll keep coming back to it though as our courses go on. So, what is an encoding? Encoding is a translation from a number to truly anything and abstraction. Some examples are social security numbers, error codes, and ASCII. These are all numbers that convert to different things. A social security number translates to a person. Error code translates to some sort of explanation. And an ASCII number translates to a keyboard key. Here's the ASCII chart. This is my favorite ASCII chart. There are many, and they all basically say the same thing, but I have a particular fondness for this one. It's one I've been using for a decade, probably. And here you'll notice there's decimal, hexadecimal, octal, and character. And decimal, hexadecimal, octal are all the same quantity, just represented in different bases. Character is the actual keyboard key that was pressed. So for a space, that's 32 in decimal or 20 in hex. There's also this row with HTML, but we can ignore that for now. So, armed with this information, it's time to try out your first problems in the Pico Gym. I'm assigning too warm, warmed up, and let's warm up. Sensing a theme here. But use your knowledge that you've been given in the last few minutes and ask any questions, and I hope you succeed in your problem set. I hope you were able to solve some of those PicoGym problems using the knowledge that you'd gained in my lecture that I gave. Now we're going to be talking about the shell. The shell, a blank black screen and blinking cursor, lines and lines of scrolling text and someone in front of that screen who seemingly understands an incomprehensible flow of information. That is the shell. That was taken from the Pico primer, and it makes me think of the Matrix again, where one of the people is looking at a computer screen filled with green text just flowing down. And I think in reality, there's no information in this screen of text, but in the fantasy world, the character says that he can tell people. He can see people, blonde, brunette, in this screen. And that's kind of what we're going for with the shell. We want you to be able to manipulate this seemingly incomprehensible flow of information for your own good and to solve challenges. The shell has a few synonyms. It's often called terminal. That's the program that you can run in Mac and Linux to get to the shell and use it. It also can be called command prompt. That has a little bit more of Windows flavor to it, but it applies to all shells as well. Bash. Now this is a specific shell, the born again shell. And it's the most common one in Linux systems. And PowerShell. That is strictly Windows. It's quite different, but it's a shell in its own right as well. So if there's the shell, what's the counterpart to the shell? And that's what we're all more familiar with. We're more familiar with graphical interfaces. These can be point and click, like desktops, laptops, servers, or they can be touch, like phones and tablets. So why would we want the shell when we have a perfectly good interface to the system with the graphical interface? Well, the shell is fast, probably faster than the graphical interface in any endeavor. It's powerful, you can do more with it, and it's automatable. You can automate graphical interfaces as well, but it's very painstaking. You have to measure pixels and plot points on a screen that are given to moving anyway. But with the shell, it's just text, so it's a lot easier. And finally, it's just cool. I can be doing something really mundane in the shell, like editing a to-do list, and someone behind me is like, wow, you're so smart. How do you even know what's happening? And I just say, it takes years of practice. But it is simpler than it looks at times. So let's do a side-by-side comparison of some operations for the shell and for graphical means. Okay, so creating files and folders. So this is the graphical means of accessing my computer. It's just called files in Ubuntu. Okay, so I've navigated to a folder called Gen Cyber, and it has this strange file existing already called 84-0.txt. So just to alleviate the mystery of this file is actually just Frankenstein taken from Project Gutenberg. We'll use it later. So how do I create a folder with the graphical interface? Well, it's all about finding buttons and clicking on them. And here's a button for a new folder. So you can see I have a new folder in this folder. And I will show how to do that in the shell. This command shows all the contents of a folder. You can see that Frankenstein file and also the new folder I just created. So how do you make a folder in the shell? It's using the make dir command. And you can see that newer folder pops up in the graphical interface immediately. And if I were to delete these folders the graphical way, I could hold down Shift and select multiple folders and hit delete. Or with the shell, I could enter a command like this to delete them all in one line. So that command is remove and then recursive and force, which are brave options to use with RM. You might have noticed with the graphical interface, it gave me the option to undo what I'd done, and that was actually pretty nice. But with RM, there is no undo operation, so you have to be careful with that command. But it's basically just deleting a file or folder. Then creating a file. I haven't found a way to do this in Ubuntu with the graphical method. That's a new window. So surprisingly, that's something just the shell can do. Use the command touch. See that file pops up right away. On Windows, it's actually easier to create a file using the graphical interface. You can just right click and create a bunch of different files. But that's not true in Ubuntu. All right, so how do I start GIMP? Well, the best way to do that, I believe, with the graphical method is by hitting the OS key and then typing GIMP. This will be different for different operating systems, but most nowadays have this functionality where you can search for a program after hitting the OS key. See, there's GIMP. Make a picture. And that's pretty easy in the shell too. Arguably a little bit easier. I didn't have to press any extra buttons to search for anything. Now installing GIMP. This is somewhere that the shell really shines because graphically you have to just search for it online. So there's a lot in here, but it recommends Software Center, which I don't actually even have because it doesn't work on my setup. So that's a lot, but here the shell really shines because it's as easy as I already have it installed, but if I didn't, it would have installed with that command. To try to just briefly break this command down, sudo is like do something with elevated permission. You need to have admin permission to install programs on a computer or on Ubuntu. APT is the software management system for Ubuntu. We want to install, and then the program we want to install is GIMP. But as it says right here, it's already at the newest version, so there's really nothing to do. But that was a lot easier than trudging through the internet trying to find a good tutorial on how to install GIMP through Software Center. But that's not to say that the shell is always the best way to do a task. That's kind of highlighted in the next thing we compare. So to edit text in the shell, you can use nano. What I just did there is something I'm going to harp on a lot, using tab. So tab is like a magic key that auto-completes matching file names. And this is going to save you in how much you're typing and also trying to spell things exactly right, because it will spell it right 100% of the time. The more common situation is that I've misspelled something up to when I hit tab and then it won't complete. So if I were to do FL for file, now tab doesn't do anything. If I just do F and hit tab, it auto completes the file name and saves me a lot of work. Okay, so this is an empty file, and you can write hello world. We'll exit by hitting Control X. Save the buffer, save the file, yes. File name to write, file.txt, yes. Press enter. Okay, so now cat can list what's in a file. And now we see hello world is in that file. And yeah, just double clicking on it brings up the graphical way. It has the same text because it's the same file. And add a little bit more flavor text. Save it with Control S. Close. Cat it again. There it is. So as you can see, we're working on the same file through two different means. And with editing text, if I'm just doing something quick, I'll use a command line text editor. But if I'm doing something more involved, like any programming language task, then I'm more likely to use the graphical method, actually, because it doesn't really show here, but it has a lot of methods for having multiple tabs and different syntax highlighting of words and phrases. And finally, arithmetic. I guess you could do Wolfram Alpha. Took me a while there. And this would kind of be like a graphical method of doing mathematics. The shell actually has some capability for that too, using Expr. So I can do some math just right in the shell for you, if that's ever useful. So you might be wondering what that is. And that is the web shell prompt, which I will show. So I have to reconnect because I was idle for too long. Did my password right the first time, that time. So here's this line of text. So I'm typing to the right of that $sign. So this bit of text I will explain forthright. So piece by piece. Cyreal Pico CTF is the username. So that's what I'm known as in the system. And if you were paying attention, you'd see that I actually logged in as just Cyreal, but the system adds a -Pico CTF to the users on the machine. Then @ is just a separator between the username and the machine name, and the machine name is web shell. And then the colon is another separator between the machine and the current directory. And tilde is home. That's good to remember. Finally, the $sign is a separator between the prompt and the command that's being entered. And you can see that it's a little different on my local system. These prompts can differ. And see, mine has this date and time stamp, which can be useful when you're trying to debug programs. And bash is my shell that I'm using. And sometimes numbers appear in here, which are error codes. And here's my current directory or my working directory. And then I have the username and the machine name, which is named after a dragon in Morrowind. I don't know. I'm kind of weird. I like to name electronic devices after dragons. Sometimes I reuse the names, sometimes I make them up. But so commands, that's really the heart of the shell, is entering commands. There's all kinds of different commands. The simplest ones are just a program with no arguments to it. One example of that is the program called yes. So that's very useful. It prints Y to the screen 1,000,000 times or more, depending on how long you let it run. And here's where another tip comes in handy. So I actually can't type anything right now or do anything. And my computer is starting to overheat. So what you want to try in this situation is Control-C. And most of the time that will stop it for you. And you can see that error code 130. I'm not sure what that maps back to. Sometimes the error codes I recognize, sometimes I don't. That program actually is useful if you're installing a system and you're trying to update a bunch of programs and you just want it to go through. apt will actually ask you if you want to continue or not a bunch of times. And if you're just piping Y into the program, then it will just keep on going. It's kind of a brute force solution to a problem, but it works. Nano, we've actually already seen this. This can be invoked without any arguments and just starts up a blank page, a new buffer. Python 3 is a programming language. So when you invoke Python 3 in the shell, it gives you a new shell that's the Python shell. And that can do Python things. And this is actually terminated with Control-D. And then, the next more complicated invocation is a program with one argument. Nano can just do one argument. There's our wonderful file. I've been using this command already, but I've explained it, but repetition is good. ls-al lists all the contents of a folder that you're in. So for me right now, it's listing everything in tilde/testing/gencyber. And if you remember, tilde is short for home. And cd ... This is a very useful command because it goes to the parent directory. It leaves your current directory to the directory right above it, which for me in that case was testing. And then to go back to the gencyber folder, I can simply type cd gencyber. The slash is optional. And then some programs can take 2 arguments. This is probably the most complicated command so far. It's echo hello to test. So we have a new file. If we cat it, we see that has what we echoed in it. This says to redirect output to a file, and we called the file test.txt. Okay, so this is where Frankenstein comes in. So grep is an extremely useful tool that searches for patterns in files. So I'm going to search monster in that file. These are all the lines that contain monster in Frankenstein. Grep is one of those tools that really make the shell powerful. Clear is a good no argument command. It just clears up your terminal. This last one, chmod +x bin, we'll go over that more later. But what it does is it makes a file called bin able to be executed. So this can be important when you're downloading programs or using new ones. So one of the most common arguments to command line programs is paths. And a path is an address to a file, and it can be either relative or absolute. And absolute is the easiest to understand. It's any path that starts with the /, because that's starting at root. If I do print working directory, I'll see the whole path to where I'm currently working in the shell. And I can use this to save myself some time with making an absolute path to our test.txt. So relative paths are what we have been using. They're sort of intuitive. So I'm in the Gen Cyber folder, so I can reference everything in it by just typing its name, not needing to type this entire path leading up to it. So it's two different ways to address the same file. So this can be daunting, but I swear you do get some muscle memory for it pretty quickly. And the best way to do that is to get a cheat sheet that you can quickly reference to kind of remember what you can do in the shell. And this is a good one. See, it has some of the commands we've been mentioning already, like print working directory, remove, cd, ls, ls-la, make dir, cat. It has all these really useful practical commands just at a glance. So I recommend really printing this out. That way it doesn't have to take up screen space for you, but to each their own. So here's something I want to show. I'm not going to demo it. I could demo it during our Q&A session, but for right now, I just want to show this shell navigation demo. So if you go to picoctf.org, click the Learn tab, Primer, go to the shell, and then go to What the Shell subsection. You go down a little bit, you'll see the shell nav exercise. This will walk you through learning cd and print working directory and make dir and all of these commands that I've been using, but it'll help you start using them and start building that muscle memory in the shell. I can't emphasize enough to use tab. Experiment with using it. If you hit it twice, it'll list all the possible completions to your word if it doesn't complete by itself. Just see where it works and where it doesn't work. And don't be afraid to always try tab. And again, that Control C, if you get stuck in something and you can't really type anything, Control C is going to save you there. All right, and here's the final problem set for this section. In the Pico gem, it's obedient cat, wave a flag, convert me.py, and what's a netcat. And obedient cat can actually be solved really easily using a browser and graphical methods, but I would implore you to use the shell. Follow the hints. Don't be a hero. The hints are there for a reason, and they'll help you solve the problem using the shell. So with that, that's our general skills in CTF's lecture, and we hope to see you in the Q&A session.